Did you know that nearly 1/3 of Finland's land area is covered by peatlands? These unique wetlands are incredibly efficient at storing carbon. While covering only 3% of global land area, peatlands store up to 30% of global soil carbon. However, peatlands are also sources of greenhouse gas emissions. And when humans disturb these environments, emissions typically increase. After the Second World War, Finland rebuilt itself by draining peatlands and planting forests. By 1980s, more than half of our peatlands had been drained for forestry, resulting in almost 5 million hectares of peatland forests, an area larger than Denmark. Many of these forests are now ready for harvest, but clear-cutting a peatland forest can quickly alter the water table and increase greenhouse gas emissions. One way to address this is by fertilizing the forest with ash. While the effects of ash on tree growth are well known, its effects on soil remain unclear. The changes in pH, nutrients, and ground cover can change the soil microbiome, and this in turn can lead to changes in greenhouse gas emissions, carbon storage, and overall biodiversity. So as the use of ash is increasing, it is crucial to understand its effects on soil. We often talk about soil storing or releasing greenhouse gases, while in reality, it's the soil microbes doing the work. In water-saturated peatlands, microbes that can live without oxygen are consuming and producing methane. And when a peatland is drained, the soil becomes aerobic and microbes start breaking down the peat and producing carbon dioxide into the atmosphere. In my PhD, I study 8 drained peatland forest sites, each with a control site and an ash fertilized site. I compare the soil microbiome between these sites to see how ash affects them. With modern DNA-based methods, I'm able to dig into these invisible communities to see who is there and what they're doing. To grasp the greenhouse gas balance of a forest, we must understand the organisms responsible for it. And this is why we need to look underground. Thank you.